Good morning, students. Today we are going to see Chapter 4 Algorithmic Strategies. An algorithm is a strategy that always guarantees in the correct answer. A strategy might yield incorrect results. Learning objectives. After studying this chapter, you will be able to know what is meant by efficiency of an algorithm, what is the method for determining efficiency, and what is meant by space-time trade-off, what is meant by asymptotic notations, what is the difference between best, worst, and average case efficiency. Efficiency of an algorithm. An algorithmic efficiency is a property of an algorithm which relates to the number of computational resources which used by the algorithm. Here the way to measure the efficiency of an algorithm is to count how many operations it needs in order to find the answer. That is, it across different input sizes to get the various results. Here the efficiency of an algorithm depends upon its time complexity and space complexity. Here the efficiency, which is defined as the number of computational resources used by the algorithm. Here, maximum efficiency of an algorithm, we wish to minimize the resource usage. The important resources such as time and space complexity cannot be compared directly. So, time and space complexity would be considered for an algorithmic efficiency. Methods for determining efficiency. Here the efficiency is measured as the ratio of the useful output to the total input size, which can be expressed in the form of minimize the waste of resources such as time and space complexity. Here the efficiency of an algorithm, which depends on how efficiently it uses both time and memory spaces. Time efficiency, a measure of amount of time for an algorithm to execute. Here an time efficiency, which is measured by different factors. Here time efficiency is nothing but measure the total time it takes to run. It's nothing but the execution time of an algorithm. Here the time efficiency of an algorithm, which is measured by different factors. For example, suppose we write a program for a defined algorithm, execute it by using any programming language, and then measure the total time it takes to run. Here this execution time, which measure in this case, such depend on a number of factors. First one is speed of the machine. It could consider as the machine speed. And next one is compiler and other system software tools. Here it converts some machine language. Here it determines how efficiently an algorithm that solves a given problem. If we want to determine how the execution time is affected by the nature of the algorithm, because of this should develop some fundamental laws that determine the efficiency of an algorithm in terms of the nature by understanding the particular problem that is implemented in any programming language which is defined in the algorithm. Space-time trade-off. Trade-off is nothing but where one thing increases and another must decreases. Here, space-time trade-off is a way of solving a problem or calculation in less time by using more storage space. Here, calculate the less time. Here, the time decreases but storage increases. Otherwise, here we want to solve a problem in another way, very little space by spending a more time. That is, space decreases, time will be increases. In this case, where an algorithm or a program iterates increased space usage with decreased time. Here the space refers to the data storage consumed in performing in a given task, and the time refers to the time consumed in performing a given task. Time space trade off. Here, a time space trade off which refers to a situation where we can reduce the use of memory space at the time of execution, and also if we can implement it in any programming language where the algorithm is defined by reducing the time, that is the running time, by increasing the cost of memory usage. Here, these factors which we can reduce at the moment, if we want to reduce the memory space but increase the time. If we want to reduce the time but increasing the memory space. Here, this type of situation which we handle by using this time space trade off. Here, this way which is best algorithm to solve a given problem because it requires less space in memory and takes less time to execute its instructions to generate output. Asymptotic notations. Here the asymptotic notations or languages that allows us to analyze an algorithm's running time by identifying its behavior as the input size for the algorithm. If the algorithm input size increases, we can identifying the behavior of the algorithm. That is, what is the running time of an algorithm. This is also known as the algorithm's growth rate. Here, these expressions that are used to represent the complexity of an algorithm. Here there are three asymptotic notations which are mostly used to represent time complexity of algorithms. First one is big O, second one is big omega, and third one is big theta. Big O is nothing but it describes the worst case of an algorithm. Here, what is meant by worst case? Here, a notation it describes some limiting behavior. That is, if you want to search an element in a list, if we find the element at last, or if the element is not found in the list, here this type of an algorithm which we could consider as the worst case. Big omega. Here big omega which is used to describe the lower bound, that is best case of an algorithm. For example, if we find an element in a list, for example, if we search an element in a list, if we find the element at first element in the list, if we find element at first, here this type of algorithm which is the best case of the algorithm. If we find the element first, no need to compare more things more times, it takes less time to execute. Because of this, it considered as the best case of algorithm. Big theta. Here an algorithm which has the complexity, that is both lower bound and upper bound are equal. Here this type of complexity which we say that average case of an algorithm, that is both lower bound equal to upper bound. It actually has a complexity which means the running time of the algorithm which always falls in best case and worst case. Here this type of big data which considered as the average case. Here the average case is nothing but it should be part in the both cases, both running time and memory spaces are calculated equally. Suppose if we search an element in a list, if we find the middle of the list, we could able to find the element in a list. Here this type of the cases are under big theta. Best, worst, average case efficiency. Here we consider an example, a list of number of values which is stored in an array. Suppose if we want to search a particular element in this list, here the algorithm it searches the key element, and by comparing the key element which each and every element in the list sequentially, by comparing this element we could able to differentiate what is best case, what is worst case, and what is average case efficiency of an algorithm. Best case, let me see example. Suppose if we want to search a particular element in this list, here the algorithm that search the key element in the list among the elements by comparing the key element with each element in the list sequentially. Here the best case, it would be if the first element in the list it matches with the key element to matches with the key element to be searched in a list of elements. Here the efficiency it should be expressed as big of O, which means only one comparison is enough. So it can reduce the running time as well as the storage space. Let me see this example 12, 13, 14, 15, 16, 17, 18. Here the target element is 12. So here the 12 in this list, here 12 is the first element. So among the list of elements, we could able to find the first element in the list. Because of this, it should be considered as the best case algorithm. If the first element in the list, it matches with the key element to be searched in a list of elements. அதாவது நம்மளோட டார்கெட் எலிமெண்ட் ஃபர்ஸ்ட் எலிமெண்ட்டில் இருக்குது அப்படின்னா இந்த அல்கோரிதத்தை பெஸ்ட் கேஸ் அல்கோரிதம் அப்படின்னு சொல்லலாம். Worst case. Here the worst case is nothing but if you want to search a particular element in the list, the algorithm that searches the key element in the list among the n elements by comparing the key element with each element in the list. If it is the worst case, if the complete list is searched but we can't find the element, or we can find the element at the end of the list. Here this type of the searching element in the list, here this type of the algorithm which could be considered as the worst case. Here the example is target element is equal to 18. See here the lowest element, that is comparing all the elements, at lowest we could able to find the target element. Because of this, here this algorithm is the worst case. Here the worst case of an algorithm which should be expressed as big of n, because n comparison it required to complete the search. Average case efficiency. Here the average case efficiency of an algorithm is nothing but by finding the average number of comparisons. Here the minimum number of comparisons which should be expressed as 1 and the maximum number of comparisons which should be expressed as. Suppose if the element is not found, here the average number of the comparisons, here the minimum number of comparison is n. If the average number of comparison is n plus 1 by 2, here the average case of efficiency which could be expressed as big of n. Here the average case is nothing but if we search an element in the list, suppose we could able to find the middle element in a list, so it should be considered as both best case and worst case. That is here the upper bound which is equal to the lower bound. Let us see a quick review in book. Efficiency of an algorithm. Efficiency of an algorithm. Here the computer resources which are limited that should be utilized efficiently. Here the efficiency of an algorithm which is defined as the number of computational resources and used by the algorithm. Algorithm ஒரு அல்காரிதமோட எஃபிஷியன்சி வேணும் அப்படின்னா அங்கே எவ்வளோ காம்படிஷனல் ரிசோர்ஸஸ் யூஸ் பண்ணுறோம், அதாவது அந்த அல்காரிதத்தை கால்குலேட் பண்ணுறதுக்கு என்னென்ன ரிசோர்ஸ் யூஸ் பண்ணுறோம் அப்படிங்கிறத வச்சு தான் ஒரு அல்காரிதத்தோட எஃபிஷியன்சி சொல்லுவாங்க. Here the efficiency of an algorithm can be measured based on the usage of different resources. If a maximum efficiency of an algorithm, we wish to minimize some resource usage. Here the resources are time and space complexity. Here the time and space complexity which we cannot be compared directly, but it could be considered as an algorithmic efficiency. Here the methods are, if we want to find the efficiency of an algorithm, it depends on how efficiently it uses time and memory space. Nothing but execution time and memory space is allocating memory space. Here the time efficiency of an algorithm which is measured by different factors. Write a program for defined algorithm if we execute it by using any programming language and measure the total time it takes to run. Here the execution time that measured, in this case we depend on a number of factors such as speed of the machine, compiler and other system software tools, operating system, programming language used and volume of data required. Here these are the things which used to determine how efficiently an algorithm which solves a given problem. Here its execution time is affected by the nature of the algorithm. Because of this, we need to develop some fundamental laws that determine the efficiency of a program. Space-time trade-off. Here the space-time trade-off is nothing but space-time or time memory. Here the trade-off is one thing increases and another thing decreases. If the space increases, time decreases. If the time increases, space decreases. Trade-off அப்படின்னா ஒரு பொருள் ஏறணும், இன்னொரு விஷயம் இறங்கணும். அப்போது இங்கே டைம் அதிகமாக இருந்துச்சுன்னா ஸ்பேஸ் கம்மியாக இருக்கும், ஸ்பேஸ் அதிகமாக இருந்துச்சு அப்படின்னா டைம் கம்மியாக இருக்கும். Here to solve a given problem by using many algorithms which we may be used. Here the sum of the algorithms which may be extremely efficient. Here some algorithms are extremely time efficient and some algorithms are extremely space efficient. Here time space trade-off, which refers to a situation where we can reduce the use of memory at the cost of slower program execution, or it reduces the runtime at the cost of increased memory usage. Here the asymptotic notations. Next we are going to see asymptotic notation. Asymptotic notations are languages which we use meaningful statements about time and space complexity. Here there are three asymptotic notations to represent time complexity of algorithms. First one is BICO. BICO is nothing but it describes the worst case of an algorithm. Big omega. Big omega is the reverse of BICO. Big omega. Here big omega is the reverse of BICO. BICO is used to worst case of an algorithm. Okay, is the reverse of the big O. Here the big omega is used to describe the lower bound, that is best case of the algorithm. Big theta, when an algorithm has a complexity with lower bound is equal to upper bound. Here an algorithm that has the complexity of big of n log n and theta of n log n. It's nothing but average case. Here the lower bound which is equal to the upper bound. Best, worst and average case efficiency. Here let we assume a list of numbers which is stored in an array. ஒரு அரேயில் ஒரு லிஸ்ட் ஆஃப் நம்பர்ஸ் ஸ்டோர் ஆகிருக்கு. இப்போ அந்த அரேயில் ஃபர்ஸ்ட் ஒரு எலமெண்ட், இப்போ நம்ம ஒரு டார்கெட் எலமெண்ட் வச்சுருக்கோம், அந்த எலமெண்ட் அது இந்த அரேயில் உள்ள ஃபர்ஸ்ட் எலமெண்ட்டோட மேட்ச் ஆயிடுச்சு அப்படின்னா அது பெஸ்ட் கேஸ். சப்போஸ் அந்த பெஸ்ட் கேஸ் அப்படின்னா நம்மளோட டார்கெட் எலிமெண்ட் ஃபர்ஸ்ட் எலிமெண்ட்டோட மேட்ச் ஆனால் பெஸ்ட் கேஸ், டார்கெட் எலிமெண்ட் லாஸ்ட் எலிமெண்ட்லேயோ இல்லை அந்த லிஸ்ட்லேயே இல்லை அப்படின்னாலோ worst கேஸ். அதே மிடில் எலிமெண்ட்டில் இருந்தால் அதுக்கு பேர் ஆவரேஜ் கேஸ். So here the best case it should be if the first element in the list matches with the key element to be searched in a list of elements. The worst case if the element is found only at the end of the list or is not found in the list. Here the average case efficiency of an algorithm which is obtained by finding the average number of comparisons. Obtained by finding the average number of comparisons. Here the minimum number of comparison is 1 and maximum number of comparison is n. Suppose if we cannot find the element, here the maximum number of comparison is n and the average number of comparison is n plus 1 by 2. Here this average efficiency will be expressed as big O of n. In the examination point of view, here the book back question is write a note on asymptotic notation. In this session we learned what is efficiency of an algorithm, what are the methods for determining efficiency, what is space-time trade-off, what is asymptotic notation, and what is best, worst and average case efficiency. I hope you all understand. Let me see the next class what are the searching techniques which we used for algorithm. Thank you students.